Hello, welcome to the solution to problem of the day, post 0722. So part A was just perform the traditional cross the product of these two vectors, A cross B, and we all know how to do this. So we got in row one our basis vectors. This is vector A components, vector B components. So we block out this column and this row, take this determinant, 2 times 1 is 2, minus 2 times 3 is 6. We get a negative 4. The second one, you have to put a negative here. This is very important. Remember, it goes positive, negative, positive. Block out this column, block out this row. We go 1 times 1 minus 3 times 3 will give us a negative 8, but a negative 8 times a negative is a positive 8. Block out this column and this row. 2 times 1 is 2, minus 2 times 3 is 6. We get a negative 4. Okay, so that is the traditional way we were all taught. And it looks like this. Okay, so we got vector A, vector B, we cross those, and we get this. And you can see it is negative 4, positive 8 in the xy plane. Flip it over, and we see it is negative 4 on the z-axis, the negative z-axis, E3 axis. Okay? So, part B, here is our vector again. We want to use the Levi-Civita permutation tensor. All right, so here's the way I do it. I'll make my little diagrams like this, the positive and negatives, and I got my I, J, K's in order here, right? So when I write down E1, I want to do everything with E1 first instead of doing all the positive ones first. So as an example, I do 1, 2, 3, and I know that's positive, right? So this is E1, A2, B3. I'll write that down. The next one I'm going to do is the negative, which would be, do you see the arrows? 1, 3, 2. So it's going to be 1, A3, B2. Do you see what I'm doing? Then I do E2, right? So I start at 2. I go 2, 3, 1. Just write down 2, 3, 1. Then I go to the negative side, right? I start at 2 and I go 2, 1, 3. 2, 1, 3. Right? I think this makes it really easy to do it this way. I did the E3 the same way. Here's my two vectors. I fill in all the numbers, and we obviously get the same answer, right? Negative 4E1 plus 8E2 minus 4E3. Okay, the last one we're going to do is a wedge product. And this happens to be my favorite way to do the cross the product, but it's tricky if you're not used to doing it. Once you get the hang of this, it's really quite easy, especially in Cartesian coordinates with orthonormal basis vectors. It's very easy. Okay, so here's what we're going to do. We're going to wedge A with B, and remember the rules. E1 wedge E1 is 0, right? All of anything wedged with itself is 0. So we should get 9 terms. We're only going to get 6, okay? So we got E1 wedge E2, E1 wedge E3, E2 wedge E1, E2 wedge E3, E3 wedge E1, E3 wedge E2. That's what all this is, okay? Now remember the other rule, and that is that we can take the opposite of this. So here's E1 wedge E2, and here's E2 wedge E1. If we flip this, that becomes a negative. So we got 2 minus 6 is minus 4 E1 wedge E2. The same thing here. We got an E1 wedge E3. Well, here we got an E3 wedge E1. If we flip that, we got 1 minus 9 is minus 8, E1 wedge E3. And the last one is E2 wedge E3 here, and E3 wedge E2 there. So it'd be 2 minus 6 is minus 4. Okay, now you're saying, okay, well, what the hell does this mean? I got these things here. What do I do with these things? All right, this is the part that it takes some experience, but once you see it, it's really obvious. Okay, let's get this stuff off the board. Let's put our orthonormal basis vectors on here. Let's blow this up so we can see what we're doing. Okay, there they are. So this is E1, E2, and E3. Dear Desmos, when are you going to let us do labeling in Desmo 3D? It's been years. Get your finger out. Get it done. Okay. So when you say E1 wedge E2 like this, it'll look like that. You get this oriented plane called a bivector, and you see that the edges are 1. So the area of this bivector is 1. And it's a positive direction, which means that what you're thinking of is sticks out, which it happens to be exactly the same thing as E1 cross E2. Do you see that change colors? So E1 cross E2 is actually E3, right? That's because that's the way this box is oriented in a positive way. All right, so let's get that off there. Now, what is E2 cross E3? So E2 wedge E3 is going to be positive in this direction. So that becomes the E1 basis vector. Do you see that? It becomes the E1 basis vector. And here's the last one is E1 wedge E3. So E1 wedge E3, I'm going counterclockwise, which means it's positive in this direction, which means what? See, it is a negative E2. So this is the part that makes this a little bit tricky, is knowing that E1 cross E2 is positive E3, E2 cross E3 is a positive E1, and E1 wedge E3 is a negative E2. So once you know that, then you can just go right back here and fill these in, right? So this E1 wedge E2 becomes a positive E3. E1 wedge E3 becomes a negative E2. So that negative changes that negative to a positive. And then E2 wedge E3 becomes a positive E1. So this is exactly the same thing we got. We got a -4, a positive A, and a -4. Okay? Wasn't that fun? I'll see you later.